So today we're going to be talking about psychophysics, where the whole is not necessarily the sum of its parts. Psychophysics is defined as a study of quantitative relations between psychological events and physical events, or more specifically between sensation and the stimuli that produce them. For example, think about when you've had a hearing test, when you had the headphones placed on both ears and you're asked to determine when you hear sounds. So, psychophysics thinks about how much more intense must a stimulus be in order for us to perceive a change in that intensity. Psychophysics tells us that the amount of change depends on the initial intensity that we, in that case, would hear. A quiet sound needs to be turned up less than a louder sound. Also, you might refer to how do you know when you turn up the TV volume that it's actually getting louder? So, as you guys are viewing this, think of this example. If the room you're in is already bright and you add an additional light, when does your perception of that brightness change? If you start with the room mostly dark and then you add the additional light, there's a large change in perception of brightness. But if you have the room already bright and you added an additional light, you might not detect that new stimulus. All of us would have a different perception of when that light in our room gets darker or gets brighter. What we're going to talk about is that's called our absolute threshold. At what point can we detect 50% of the time that stimulus? Or if given a particular stimulus, the minimum stimulation needed for detection. So at what point do you notice, as I referenced before, when the volume on your television has increased, even though you might have hit it 5 or 6 times? If you're watching television with a family member, your absolute threshold for that volume control could be slightly different than others' perceptions in the room. Another example of our absolute threshold is you see two friends talking on the other side of an empty room. You can't hear what they're saying, but you start to walk towards them. At some point, you're going to recognize a sound when you hear what they're talking about, and that point is your absolute threshold point. When you're turning up that volume, if you're sitting with different age groups in that room, you will notice that young people tend to hear the difference, the absolute threshold, a little bit earlier than an older person. We know that thresholds do increase with age. This means that it takes more of a stimulus to be detected by an older person relative to a young child. If we think back to our Unit 1, what is the operational definition of an older person? So you have to be clear about that if you are actually conducting an experiment on absolute threshold. Are you talking about someone in the age group of 60 to 80 years old as being old? Or perhaps your interpretation of older person is someone just older than yourself. So we have, as people, different thresholds. The minimal change in our stimulation that can be reliable, detected 50% of the time. This is called our just noticeable difference. You also see it referred to as JND. So for example, if music is playing on your computer and you hear it, how much of that volume change is necessary before you notice it got louder? And as I mentioned, it could be different thresholds for different people based upon age. Another example I like to think is if you're lifting weights and you have a 25 pound weight on one side and a 30-pound weight on that other side, do you notice the difference? At what point would you see a difference as you go to lift? Would a 25-pound weight feel different than a 26-pound weight? Certainly, a 25-pound weight would feel different than a plate of a 45-pound weight. So what is your just noticeable difference? So what point does that weightlifter begin to notice a change in the actual weights that are on each side? Well, this is, again, what we call our difference thresholds. How much of a change is needed to detect? And it depends. It depends on the stimuli. Ernst Weber came up with what is called Weber's law. He states that our just noticeable difference is constant proportion to the strength of the original stimulus. So there's an example listed here. If you drink coffee and you're putting a sugar cube into the coffee, maybe you just need 1/10 of a cube to notice an additional sweetness. If you have 20 cubes of sugar already in your coffee, though, you would need 2 cubes more to notice an additional sweetness. This leads us to our signal detection theory. This theory states that the detection of a stimulus depends on both the intensity of the stimulus and the physical or psychological state of the individual. So essentially, we notice things based upon how strong they are and how much we are paying attention to it. If you are a person who lifts weights on a consistent basis, you're probably a lot more attuned to when there's a change in the weight on each side of the bar. But if you don't have that experience as a weightlifter, perhaps you have a different perception and you have a different detection of that stimuli. In our participation activity, 3.P.1, the signal detection activity, you need to click on the image to read a real-life example and take part of a simulation where your signal detection skills will be tested. You must email yourself the response and then submit the assignment to earn credit for the 3.P.1. So for example, if you click on the hit button, you will come up with a signal detection experiment that we would like you to take part in. So if you think about your receptor sensitivity, we know that things are subject to change over time. Think about the watch or the ring you might have on your wrist or finger. At what point do you stop noticing that is actually present, that you're wearing it every day? And so sensory adaptation often occurs when you have a decline in your ability to perceive or feel that receptor activity when the stimuli itself has not changed. It's still been there the entire time, but there's a point where you start to no longer feel it. For example, have you ever walked into somebody's house who has pets, and you walk in, and right away as you enter the room, there is a strong odor that might be unpleasant to you? But the people who have been living there, they don't notice that the house has that unpleasant odor. They have adapted to that sense of smell because over time there's been a decline in their receptor activity towards that smell. Walk into a room where a turkey's baking. At first it smells great, but eventually you don't notice it. And that's normal. Our brain tends to filter out different sensory information that we don't need on the present time. Habituation or adaptation is a decline in a response to a stimulus due to repeated presentation of the stimulus. So let's say your neighbor's yard is being mowed while you're on a Zoom call. At first, it's annoying and it's loud, but eventually you tune it out. Again, you have sensory adaptation.